All right, we're picking up with Unit 1, Lesson 14, and we're going to be doing, starting with example 3 in this video. And again, we are in Chapter 6, Lesson 5 of the textbook, talking about operations with radical expressions. So we're on the concept summary slide right now, talking about how to simplify radical expressions. And the concept here is that a radical expression is in simplified form. It's fully simplified form when the following conditions are met. It says the index n is as small as possible, and index is, if I pull up my drawing toolbar real quick, if I take the root of something, the nth root, that's the n that they're talking about when they say the index. It's this root, so it's like the square root or the third root or the fourth root. That root needs to be as small as possible in order for something to be fully simplified. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. And so all this stuff under here, this is where you have your radicand. The radicand can't have fractions, and you can't have any square roots or any radicals, any square root, cube root, any root can't be in the denominator. So if you have a fraction, you can't have any roots in the denominator. You can't have any fractions inside of a root. The radicand has to be fully simplified. You can't have any nth powers, and the index out here has to be as small as possible. So let's look at an example 3 here. We're going to be multiplying radicals, and we need to simplify after we multiply the two things together. So the first thing I'm going to look at is, I notice that each of these are both cube roots. So if you have the same root, you can combine these two radicands into a single cube root expression. So that's going to be, this stuff is going to be the same as 5, which is outside the first one, there's nothing else outside, times the cube root of 100 times 10, which is 1,000, and then a squared times a, which is a cubed. And the nice thing for this one is they started off by giving you something that simplifies really easily. The cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. And the cube root of a to the third power just cancels itself, these things cancel each other out, and you're left with just a. So this is 5 times 10a, which obviously is 50a. Let's check their work on this example. Notice they end up with just 50a like I did. Okay, here's one for you guys to check your progress on. Pause the video as long as you need to work on this, and when you have your answer, come on back and go to the next slide. Okay, our answer for this one is B, 24a. Okay, in example 4, we're going to add and subtract radicals. And you notice each time here we have a square root in each one, but the number inside is different. So there's going to be some manipulation we need to do to each of these problems. The first thing that we're going to do is break down this 45 and the 80 and the 20, and we're going to break them down into factors of perfect squares. So I know that 45 is 9 times 5, and 9 is important because it's a perfect square. It's 3 squared. So I have 3 squared times 5. 80 breaks down into 16 times 5. So 4 squared is 16. This is 16 times 5. And 20 is 4 times 5, and 4, you can also rewrite that as 2 squared. So this first line, we're just writing everything as squares. Then in the next line, we're going to break up each of these multiplied problems, each of these two products, as giving it its own square root. So we have the square root of 3 squared and the square root of 5, the square root of 4 squared and the square root of 5, the square root of 2 squared and the square root of 5. And then we're going to simplify everything. The square root of 3 squared, that's just 3, because it's the square root of 9. The square root of 4 squared is just 4. The square root of 2 squared is just 2. So I have 3 times root 5, that's 9 root 5, minus 5 times 4, that's 20 root 5, and then plus 4 times 2, which is 8 root 5. And you'll notice you can kind of treat, once you've gotten to this step, you can kind of treat the square roots, or the root, any root, whatever it is, this is the square root in this example, you can kind of treat those like they're variables. So you can imagine as if this problem said, in this step, imagine it said 9x minus 20x, and then plus 8x. And if we had a problem that said that, you would do 9 plus 8 is 17, and 17 minus 20 is negative 3. So this would be negative 3x. But in our case, the x is just root 5. So notice how here we have negative 3 root 5. All right, here's one for you guys to check your progress on. We need to simplify 3 root 75 minus 2 root 48 plus root 3. Pause the video as long as you need. When you have your answer, come on back and go to the next slide. Okay, our answer for this one is letter D. Okay, in example 5, we're going to be multiplying radicals this time. And you notice in this we have a term plus a term, so that's 2 terms, that's a binomial, times a term minus a term, 2 more terms. So we have a binomial times a binomial. Whenever you have a binomial times a binomial, you are going to use FOIL. So we're going to do the first times the first. 2 root 3 times 3 is 6 root 3. We're going to do the outer, 2 root 3 times negative root 3. So that's negative 2, and root 3 times root 3 is root 9. Then we do the inner, 3 root 5 times 3. 3 times 3 is 9, so this is 9 root 5. And then we're going to do the last term, 3 root 5 times negative root 3. So we have negative 3, and then root 5 times root 3 is root 15. And just like always, since we need to simplify, we're going to look for any of these terms if we can break them down anymore. I've got a root 3 and a root 5. I can't combine those at all. They're not like terms. And I've got a root 15, and 15 just breaks down to 3 and 5, but neither of those is a perfect square, so I can't break that down. But here I've got root 9, and you know the square root of 9 is just 3, so this is 2 times 3, which is 6. So all of this term is really just 6. So I'm pretty sure they'll have in their answer 6 root 3 minus 6 plus 9 root 5 minus 3 root 15. You might be able to simplify that some more, but let's see what they do. Okay, so this is where we got. Let's look at the next screen. And that's just our answer. Okay, so here's one for you guys to check your progress on. You're going to be multiplying in this one again. Pause the video as long as you need, and when you have your answer, come on back and go to the next slide. So our answer for example 5 is letter D. Okay, example 6 is a real-world example. It says we need to use a conjugate to rationalize a denominator. So this question says, in a square with side A, the ratio of a side to the difference between the diagonal and the side is A over A root 2 minus A. Use a conjugate to rationalize the denominator and simplify that expression. So hopefully you remember a conjugate is the same as this term, except if it's a plus, you change it to a minus, and if it's a minus, you change it to a plus. So what we're going to do is we're going to take this original expression and we're going to multiply by the conjugate of the denominator. So the conjugate of the denominator is A root 2 plus A. A root 2 plus A is a conjugate of A root 2 minus A. You just change the sign again. So we're going to do A times this. We're essentially distributing. So we're doing A times this, and we're doing A times A. And we're doing, on the bottom, we have a binomial times another binomial. So we're going to be foiling the bottom. When we multiply the top, when we distribute out the top, we get A squared times root 2 plus A squared. And on the bottom, when we FOIL, we get A root 2 squared plus A squared root 2, that's the O. A squared minus A squared root 2, that's the I. And then minus A squared, that's the L. You'll notice that this term and this term are identical to each other, and here this one's positive and this one's negative, so these cancel each other out. So we're left with just A root 2 squared minus A squared. So A root 2 squared is A squared and root 2 squared. Root 2 squared is root 4, and root 4 is just 2. That's how we get this 2. So we have 2A squared minus this A squared, which leaves us with just 1A squared. And notice that the numerator had, each of these had an A squared, so we're factoring out the GCF from the numerator and the denominator. We're taking the A squared out of the top, so we'd have root 2 plus 1 on top, and 2 minus 1A squared on the bottom. Then we're going to cancel these A squareds and simplify this. And that simplifies to just, you can't combine these, but this is just over 1. So your answer is just root 2 plus 1, which obviously is much, much simpler than this original expression that we had in the problem. So here's a real-world example for you guys. Check your progress. We have this fraction this time, and you're going to need to use the conjugate to rationalize this. So pause the video as long as you need. When you have your answer, come on back and go to the next slide. Okay, our answer for real world number 6 is B, root 3 minus 1 over 2. And that is the end of Unit 1, Lesson 14. Go ahead and get started on the classwork now. If you have further questions about this, please ask me in class.